Welcome to a new test and teardown video. This time it's a Heathkit Impedance Bridge model IB2A. And this one is a little bit special for a Heathkit product. But anyway, let's try and look at the front here a little bit. It consists of a generator and a detector. So the idea is you can of course change the generator level and all those settings for the generator, and this goes to your device under test. So at this and that frequency you're driving at this and that impedance, and then you can match this one. Oi, oi, oi. I will have to see if I can. Oh, this is also going. So the idea is the detector is again with, you can see here we can set some different parameters, impedances. This is of course the whole idea with this one, is to see where is the match of impedance so we can test and check our components. So this big thing here is just a reactive component tester, more or less what it's doing. And this is AC on off, and then there is this, see, AC internal or shunt meter for DC. Interesting. Internal. I want to go internal AC, internal AC. That is what we want. Otherwise we can put in an external generator or an external detector if we've got something that is more sensitive. Yeah, we can see this looks a little bit like soldering, or just a few cracks. The meters in these, they can be a little bit different from model to model. I think this is one of the older. And at the back there is not a lot to see. I'm just trying to snoop around how to open this one the easiest way. And this is a classic thing that is a little bit annoying with Heathkit. This little hole here for the main connector is of course the I mean, this size is for the USA connector, right? And this is a Europe connector, so it's not going through the hole. So now I need to bother with this case here, or maybe I will unscrew it. It's just a little bit annoying. Ooh, what is that? Just a knot, and that is how we do it. Pretty good, top quality. So let's look a little bit on the inside of this fantastic Heathkit unit. So that will be the oscillator. It's a 1 kilohertz oscillator. And we got a lot of really cool details. I mean, this one is made quite nice. Many of those Heathkits, they were bought as a kit. So you had to assemble everything yourself. But I think the guy that made this one, this was not his first Heathkit, because he made everything really, really nice and beautiful. Plenty of space around everything, so there's no risk of anything touching. And the wires here, they're not completely straight, but slightly bent, so it can actually handle, bends from the casing and normal working around with this, because this is also a classic thing with Heathkit. They're made to be cheap, so the metal sheets, they are quite thin and flimsy, and then you screw everything together and then it's becoming okay. We see they're using those 1L4 and 1U4 tubes in both the oscillator and the detector, and they are quite special and rare. I don't think I got them in my collection, so they're really, really cool. Low voltage, 1.4 volt, and only 50 milliamps of current in the filaments. Is because it's a direct heated cathode. So they warm up really, really fast and uses like really, really low power. And they're mainly used in battery powered radios and stuff like that. But for whatever reason, they thought they could use it in this unit. So that will be all the resistors for the impedance stuff. And look at this transformer here in the middle. They made it in a very, very special way with isolation in here and extra isolation. Look at the distances from the windings to the metal. And this is because they wanted to have a very low capacitance coupling between the windings and to the metal. This way we get a wider range or higher resolution with smaller value components because of that. So that's a pretty good detail. So because we are using a low voltage, low current, super low power tubes, also we can use a tiny little transformer. So this is our mains power transformer. Look at this tiny, tiny little bit. Itsy bitsy. And this is a thing with some of those Heathkit units. Look at the two thin black wires here. That is the primary mains voltage input. So this particular transformer is for Europe voltage. Other ones will be for USA voltage. And there isn't any other primary winding, so this is could be a problem if you import one of these from somewhere else. There is no winding, so it is a big problem with that, right? The secondary side, we got a low voltage and a high voltage. So the high voltage is the red wires. Let me see if I can show them. So the red wires, they go to this diode. So this, I think, is a silicium diode, and there you have your high voltage, your anode voltage, filter it and all that. And then the low voltage will be those two wires, the orange wires, and they go to this selenium rectifier down here. Let's try and move the camera a little bit like that. And this is, of course, the low voltage for the filaments. And this also goes via one of the switches, so you can turn on and off your filament. And we got some voltage drop resistors in series with the two sides of the tubes and all that. It's a little bit funny. Let's look a little bit at the schematic. At the very, very bottom, we see the power supply. And the very classic about the mains transformer input is they come in 117 or 230 volt versions. The one that I got is, of course, the Europe version, but the schematic is made in USA, so they wrote a 117 volts. And there is only this primary winding, so you are definitely going to have a problem if you import something, right? And if we look at the high voltage, we see only one silicon diode and some capacitors and a filter and all that. Then the filaments supply, they're using a bridge rectifier, a selenium rectifier, and then they make about 20 volts DC, and then this DC voltage go to a resistor voltage divider and some capacitors. And the idea about having a very high voltage and then divide the voltage down using high value resistors is, of course, a good idea in this case, because you can use higher resistors, and then you have a much better low pass filter your capacitors don't need to be so high. And this is possible because the tubes, they use very, very little filament current, only 50 milliamps. So it all makes good sense. And the fun thing is they put those two filaments in series, and they are 1.4 volts each. So two of them in series, and there you have it. 2.4 or 2.8 or something like that. It's not super critical. And yeah, they're doing this 2 times for isolation between the oscillator and the detector amplifier. The rest of this circuit, yeah, the top half of this circuit is just switches and switches all over the place. That is just amazing how many switches there is in this circuit. There's one little thing that I, of course, also changed in this schematic, and that is the pilot lamp. If you look at the pilot lamp, they connected this one to the AC side of the transformer, but I really don't want the AC currents to go through to the output and all that kind of stuff. So I put it on the capacitors to also to discharge my capacitors. Here in the detector amplifier, we got this very, very special diode, and this is a selenium small signal diode for the meter. So this reveals, of course, something about the age of this product. But I don't find any brown, burned, leaked components. So I think I will try and power this up and see if it's still working. I was also able to clean and lubricate, see? Now I can move. This is still, I mean, the toughest. And then this one is a little bit better. But why is this one so insanely tough? I think this is not pointing the right way. So I need to unscrew this. Look at that. This is all the way to the left. And then you go this way and then, oops. Here we are, all the way to the right. This should have been here, right? So I need to fix this. This was a good test. So let's try the first power up. I also want to test the on-off switch. So let's just connect 220. I adjust for old voltage because this one is directly heated and there isn't any regulation or anything like that. So I want to be a little bit careful. So this is the generator gain. I should get some. Yes, exactly. So that is good. So the generator seems to be working. Look at that. It's definitely responding. And then we got the 0 here. This is also responding. I put the impedance in the 1 kilo, and I am in resistor. And I put in a 1K resistor. So let's try and poke a little bit with this. So where is 1K? See, now we're going down to 1K. And then this one goes down to 0 when this one is in 0, of course, all the way to the end. And at 0 here we have 1K and 0. And this is where we get the lowest indication on the meter, revealing we have a 1K resistor. I think there is a problem. Look at that, how the meter is responding. I've removed my 1K resistor and it's doing some kind of poltergeist is inside this unit. This I do not like. It's probably a switch. Let's try and move a little bit here and see if we can get this. No, it's still doing that. It's not that one. There's some. not gonna. I'm really trying to figure out, because when it's doing stuff like this, it can of course also be on component level, but it's normally a switch. And sometimes when you do it like this, then you can reveal. Ah, man. This is not so good. Oh, look at that. It's already nice and stable. So this is my set 0. I can put it anywhere I want and just see. It's still moving a little bit. And you can hear it's humming a little bit when you poke around with the generator level here, you can hear. So now the generator is running real good, and then you can adjust for 0. But anyway, when I touch the metal here, I got an electric shock. That's funny. It's because my grounding wire here wasn't really touching correctly. And there was a little bit of metal in the hole here. So let's try something funny. Let's try and measure AC voltage to chassis. Oh, nasty, huh? So, so there's definitely a nasty leak in this unit to chassis. Yikes. And here we go. I just flipped the mains connector. And now it's only 14. So now it's nice and fine. And this is one of the reasons why I really like to have a protective, always a protective earth wire to whatever it is I'm poking around with. So I get 0. It's not like I need to touch this kind of stuff with my tongue or anything like that, but I really like to have low voltage, and also for a safety reason, if there is a like real phase mains to chassis, of course I could really get a nasty shock. This is just a leak currents, not that much, not enough to hurt me or anything like that, but still not super good, isn't it? Let's try another resistor. This is 2K2. So it should be 2. So I should give it more, right? I don't see a response here. What am I doing wrong? Damn it. So it's not working anymore. But this is not 0, it should be 2K. Or maybe I need to go to the 10K range, and then, because this is 10K plus this, right? And then I go down to 2. Nope. No luck with this thing anymore. Yeah. I was so happy it was actually working. I can also hear the generator is not working anymore. So I think that is more or less. The rest will be a little bit of debugging around here and play a little bit with this. It's probably the selenium rectifier for the high voltage or anything. Oi, 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 oi. It's only using 8 watts of mains power, so this is not enough to warm up anything. Yeah, I would definitely change the selenium rectifier for the meter, this weirdo one here. Well. This is the generator level. So that is working pretty good. But in resistor mode, there is nothing at all. and it's not repaired itself by poking around with this one. So, and here we go. Then you turn it off, and then you can have it here. So this is why. And when I was moving around with the, see, oh, there's a little bit. Oh, by the way, I want to show this funny feature here. See the way the frequency is moving? I think it's very unstable of several reasons. Both the top, look at that, the level, but also the frequency. Look at the frequency, how this is modulated by mains frequency. So there's probably some capacitors in here that's not working at all. This unit is driving me absolutely nuts. Look at how unstable it is. And now I changed all the capacitors and even changed the high voltage rectifier. But look at that. Oh, now, of course, because I just started the video, now it's behaving. How about that? But before it went absolutely crazy. And see, I don't know. I've been trying to clean all the switches, all the potentiometers. I've been punking around with everything, and you can see how it's going. I don't know. I think I will put this aside for today. Yeah. See, here we go. Because this is not going to be fun, because I really don't know what it is. I also took out all the tubes. I cleaned all the sockets. Can they really do this? And I don't have any spares. So that is, of course, where I have to kind of stop this project, because they are quite rare. You see? I don't know if you can see this on the scope here. Magic. All right, so thank you for watching so far. I don't know exactly what's going to happen. Maybe I will put in some updates in the description. I'm a little bit tired of this unit for today, I must say.